In this section 4.1, we're going to talk about exponential functions. So exponential functions are useful when you're talking about population growth or radioactive decay. A lot of biological functions, as far as like bacteria growing in a dish or something like that, are exponential functions. Those are the models that we're going to be looking at. Now, the definition of an exponential function is b to the x, where b is a constant, and we can write that as f of x equals b to the x or y equals b to the x. It's important to note that b must be greater than 0 and b cannot equal 1. And x is a variable, so it's any real number. Here are some examples. F of x equals 2 to the x. This is the exponential function having base 2. Here we have a exponential function with base 10. And notice that even though the exponent is x plus 1, it is a variable exponent because of the x there. Here are some examples of functions that are not exponential. X squared, yes, it does have the exponent, but notice that the exponent 2 is constant. It doesn't change. And so this is not an exponential function. This is a quadratic function. Same here. We have exponent equal to 10, and the base is variable. And so this is not a exponential function. This is a polynomial. Here, 1 to the power of x is not exponential because your base cannot equal 1. It doesn't make sense to have your base equal 1 because 1 to any power is 1. And so you would just have a constant 1, and that is not exponential. You also don't want to have your powers alternating, and that would happen if you had a negative base. The values of your function, sometimes they would be positive, sometimes they'd be negative, it'd be all over the place. This is not an exponential function. And here we have both the base and the exponent is a variable. So this is not an exponential function. Remember, the base has to be a constant and the exponent is the variable. Okay, looking at the next page, we are asked here in these examples to use a calculator to approximate each number. And the calculator function that you're going to be looking for on your calculator might look something like y to the x. And you can use calculator.net, which is what I'm going to do, and that has x to the y is there, the way they represent that. But what you do is you enter your 3 first, and then you press that exponent button, and then you enter the number 2.4. And you should get 13.97. And I rounded my answer. So give that a try and see if you get the same answer. So here I just would have, I enter my base, then I enter in, I think on calculator.net, it's x to the y, but y to the x, whichever way. And then you enter, after that, pressing that button, you enter in the square root of 3. Okay. You may need to use parentheses around that square root of 3 because you want to take the whole number. It just depends on your calculator. So you're going to go 5, exponent key, and then square root key, and 3, and then you close your parentheses on that square root function, and you should get 16.24. This is the graph of an exponential function. This particular graph has a base 2, and you're plotting in the negative exponents. The negative in the exponent is going to cause you to have the reciprocal value. So instead of 2 cubed, which is 8, the negative is going to cause it to be 1 over 8. So on the negative side here for x values, it's going to be really close. In fact, gets closer and closer to the x-axis, but it never reaches the x-axis. On the right-hand side, it's going to increase rapidly because of these exponents getting larger. So you have 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, and it just gets very large, so it increases rapidly. So the x-axis is an asymptote, and because raising a base to the power of 0 is 1, 0, 1 is going to be a point no matter what the base is for all exponential functions. And the domain is all real numbers, and the range will be all positive numbers.